let's move. We did surface integral last time. Now today we move to volume integral. From there, if you can cover the Green's theorem, then we can solve the Green's theorem also. So let's start. So for this particular one, we have what are the things we need to cover in the volume integral? Let's look at the volume integral. So let's F, vector F be a vector point function and volume V enclosed by a closed surface. So we have the volume integral is 3 F dv, and our dv is equal to the x, the y, the z. So let's look at the example. Example says if f is equal to 2zi minus sj plus y k given region bounded by the surface. Bounded by the surface s equals to 0, y equals to 0, s equals to 2, y equals to 4. Then now said z equals to x squared and z equals to 2. So we have this. So what it simply means is we know our f, we know the boundary condition. Now let's substitute them one after the other. The first one is 0. When s is equal to 0, the lower limit is equal to 0, the upper limit is 2. For y, when y equals to 0, the upper limit is 4. For z, when z equals to s squared, the one we know, equals to 2. Then we can substitute our 2zi minus sj plus yk. Don't forget the v. The v says what? The x, the y, the z. So meaning the x, the y, the z. Or let's arrange this according to the one we want to first of all solve. Let's first of all solve the z, followed by the x, the y. I will tell you the reason. The reason is very simple. Look at the x square here. So it is better we solve this one and substitute the s squared and have everything in terms of what we need from the integration, so that you will know everything will be on variable or the one that want to be on constant. Let's see it. 0 to 2, 0 to 4. Now for us to integrate this one, what do we have? We have 2z squared over 2I minus xzj plus yzk. You have s raised to square to 2. So we have the x, the y. So now let's substitute. The 2 cancel to here. We can substitute upper limit minus lower limit. So we keep the 2 integral as we move on. The 2 integrals will move on. We have z. Anywhere you see z, you substitute upper limit first. Let's deal with upper limit. Upper limit is 2, right? Which is 4. This one returns to 4 now. 4i minus 2x j plus 2y. Okay. Then minus lower limit. Lower limit is x squared. X squared, anywhere you see x, z, put x squared there. We have x raised to power 4, y so we have x raised to power 4i minus x raised to power 3 j plus x squared zk, no, sorry, x squared yk. The s, the y, stay there. So the next thing we need to do in this case is just to substitute. We don't need to open the bracket. Just play along the way it is, the way you are solving them. Now you have 2 things you are dealing with. Now let's solve the y. Because the y is the next one, integral that follows. So let's solve it. We have 0 to 2. The y will be what? Solve this one, integrate this with respect to y, integrate it with respect to y. So this one will be what? 4yi minus 2xy plus 2y squared over 2. 2y squared over 2. Okay. Minus, let's integrate this with respect to y. I will have x raised to power 4y I minus x raised to power 3 y j plus s squared. S is going to be s cubed over 3. No. It's still s squared, sorry. S squared y squared over 2. Okay. So we need the x now. So let's integrate the x. Oh, before then, we need to substitute the limit. Don't forget your limit. Your limit in this case says what? Our limit says 0 to 4. upper limit minus lower limit. Upper limit minus, that means anytime we substitute 0, we know everything will be 0 for everything because all of them contain one y or the other. So let's deal with upper limit alone in this case now. So we have 0 to 2. So substitute 4 here. What do you have? 4 times 4, we have 16i minus, this is 4. 4 times 2, we have 8xj. This cancel this. You have plus 16k. Minus, so substitute 4 again, you have 4 s raised to power 4 I minus 4 s raised to power 3 j plus s squared y squared, sorry, the y squared here is what? 16 s squared over 2. Okay. This will be what? ds. Now we are now integrate this one with respect to x. What do we have? So we have it to be 16xi minus 8x squared over 2j plus 16sk minus, well, integrate this with respect to x. You have 4s5 raised to divided by 5 minus 4s4 divided by 4j plus this is 8, 8x3 divided by 3. Okay. The limit is 0 to 2. I hope you are following me. Hello?
Hello, sir. Yes, sir.
Are you following?
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you. So we have it to be 16xi minus 4x squared j plus 16sk minus 4 over 5x5 I minus s raised to power 4 j plus 8 raised to power 3 s3. So we can substitute. Can we try it? Substitute it. Let me see your answer.
Please.
So what do we get, please?
I'm still working on it, sir.
Any other person? Olalekan, Monday, Okoji.
I'm still working on it, sir.
Okay, let's look at it together. We have it to be. Remember upper limit minus lower limit. So that should be your mindset. So all you need to do is just to substitute. We can actually open the O bracket by saying 16. Don't forget the component ijk of 2I minus 2 square will be 4, right? J plus
Yes, sir.
16 of 2K. Minus, I can open it with this negative to the other side. Minus 4 over 5 of 2 raised to power 5. I minus 2 raised to power 4 J plus, no, sorry, this is minus plus, this is turns to minus over 3, 2 raised to power 3K. Let all the I go to I, J goes to J, K goes to K. So it's very simple. Let's just simplify it further. This is 32I minus 16J plus 32K. Don't deduct them. You can't say minus this one. It's only I to I, J to J, K to K. 2 raised to power 5 is what?
32, sir.
32 times 4. 32 times 4.
130.
128.
120,
138.
128 over 5I
128.
plus 16J minus 2 raised to power 3 is what?
8.
8 times 8
64.
over 3K. So now, we will now go to component by component. Let's take I first. So what do we have? If this, add this and this together, what do you have? What do we have? Thirty-two over 1 minus 128 over 5. 5 times 32. 5
160.
160 what?
160.
160 minus
160.
38, 128. What do we have? 32,
32,
right?
sir.
Yes.
Yes.
32I over 5. So you can see what I did. So we finish all the I. So let's take all the J. You see J minus 16J plus 16J returns to 0. Right. It will be minus 0 or positive 0, you can, depending on the 0J, or some will call it minus 0. Some will call it positive 0, depend, because it doesn't have anything. So 32 minus 36. 32,
Minus 4.
oh, sorry, 32 minus 64 over 3. So 3 is here. We have minus 64 here. So here we have 3 times 32.
96.
96 minus 64.
2 over 3.
2 over 3.
That thing is 96, sir, not 94.
Oh, thank you. 96 minus 64.
That is 32. 32 over 3.
2 over 3. Okay. So that is what they ask you to do. So in case you see question like this, it's not that cheap. You need to take your time and solve it. So let's look at the one of the application. Okay. Any question?
None from my end.
Okay, let's look at this question. Any question, please? Okay. Let phi equals to 45 x squared y, and let v denotes the closed region bounded by the plane planes 4s plus 2y plus z equals to 8. S equals to 0, y equals to 0, z equals to 0. So how do we solve this problem? You need to be very, very careful in solving this problem. We are given phi, which is our question. Look at it. The solution will be integral of phi dv. We know dv is the x, the y, the z. So if we know that, and we're given initial condition x is equal to 0, y equals to 0, z equals to 0, what about their upper limit? We are not given. So what we need to do is to look at the second equation, closed region. They said 4x plus 2y plus z equals to 8. Let's say equation 1. Let's find z. Our z will now equals to what? What is z? Z will be equals to 8 minus 4x minus 2y. So that would be our z. Are we together now? So z will be this. So if z is equals to this, it implies that my z will be 0 to 8 minus 4x minus 2y. So whatever I'm doing with the z, take note of that. Now, s is a constant, and we need to integrate with respect to y. If you pick x to be constant, So if you want to integrate with respect to y now, what will happen? So let's write x constant and integrate with respect to y. That is xy plane. We're talking about xy plane now. XY plane in the sense that z equals to 0, y equals to 0, 2 so remember we said s is equals to 0, z equals to 0 rather. So it's going to be from equation 1, you have the 2, 4x plus 2y equals to 8. Now, how do you make, if you want to make y subject of formula, what do you have? Anybody? So it's going to be 2y equals to 8 minus 4x. Am I right? So in this case,
Yes, sir.
we
Yes, sir.
have divide both sides by 2. What do we have? 2.
Y equals to
You have y equals to
4
4 minus 2x.
4 minus 2.
So for integral of y, what we are going to have is going to be in this form. Y equals to 0, 4 minus 2x dy. So I'm just giving us the breakdown one by one. Because actually we are using this, I'm supposed to give us this from the onset. Let me just try and give us this diagram so that you will get, you have a picture of what we are doing. So let's say we have our y is here, our z, then our x. So this is the meeting point, which is origin. So we have it to be this. Oh, sorry. So we are talking about different planes
Yeah,
one by one.
Put you
So-
party assignment here. Oh, yeah, go and take it. Go and carry your assignment. Demilade call.
So we will be talking about it one after the other. We first of all deal with Z. I will keep one constant. We'll do the second one. Now the third one will be, we know the third one. The third one is YZ plane. Remember the one I did now, I said XY plane. That is, we are considering from here to this place, XY plane in this side. This is what we're considering. Then we keep the other side constant as irrelevant in that case. Now we are considering XY plane. For XY plane, it simply means S equals to 0. S equals to 0. Then 2 S equals to 2. we are given this from here. So how do we get x equals to 2? From here. Remember, we are considering xy plane. If you are considering xy plane, YZ plane rather, if you are considering YZ plane, what will happen to these two? We can get when x equals to 0. Since it's YZ plane, we deal with x. We're looking for x now. So orders is 0, right? Then we have 4x equals to 8. When you have 4x equals to 8, divide both sides by 4. What do you have? So you have it to be 2. That's where you have x equals to 2. So, and we know the initial condition says x equals to 0. So in this case now, when the integral of x will be from x equals to 0 to 2, the x. Please take note of that. Any question? Can we proceed?
Yes, sir.
So, and I want you guys to solve the rest. All I need to do is just to represent the question and go and solve it. I believe you'll be able to do that. So let me now write the question out. This is for x equals to 0 to 2. For y, you have it y equals to 0 to 4 minus 2x. And the last one, z 0 to 8 minus 4x minus 2y, which is what? 45 x squared y. Then we know the z, the y, the x. So if I integrate the first one, what will I get? If I integrate the first one, I'll have x equals to 0 to 2, y equals to 0 to 4 minus 2x. So it will be 4x squared y z into z equals to 0 to 8 minus 4x minus 2y. dy dx. Remember what we did the upper one. Anywhere you see y, anywhere you see z, substitute this value. You know, this entire one is 0 already, so you don't need to do that. All you need to do is 0 to 2, 0 to 4 minus 2x. Now let's solve this one where you said 45x squared y into 8 minus 4x minus 2y. dy dx. You can open the bracket or you can leave it the way it is and continue your integration until you reach the final stage. Any question, please?
None, sir.
I can factorize 45 here. Just take 45 out so that it won't look.
Hello, sir.
Yes, go ahead.
So that means that once we are done with this, then we substitute, we take the other one, we open it up also, then we take the last one also.
Yes, I can do this one now. Look at this. I can do it this way. I can say, remember I've taken 45 out. We have x squared y. So it simply means I will go to have 8 squared y minus 4s cubed y minus 2s squared y squared. That's all.
Okay.
Yeah. Do you get it now?
Yes, sir.
dy dx. I can now go ahead and integrate y again with respect to y now. If I integrate with respect to y, don't forget my 45 is here. Integral of 0 to 2. If I integrate with respect to y, I'm going to have 8x squared y squared over 2 minus 4x cubed y squared over 2 minus 2x squared y cubed over cube. Then 0 to 4 minus 2x dx. So I'm going to have 4x 45 into 0 to 2. Then this is 4 x squared y squared minus 2 x cubed y squared minus 2 over 3 x squared y cubed. 0 to 4 minus 2. Remember, you are doing paper and pen. So you have to be explanatory. You have to simplify everything. Don't just jump the step. If you jump the step, they will jump your mark. So substitute upper limit now. So we have upper limit, remember, is y. So it's going to be 4x squared into 4 minus 2x minus 2x cubed into, don't forget it's squared, 4 minus 2x squared minus 2 over 3 s cubed into 4 minus 2s cubed. Everything ds. So you have to open this one by one. Is that okay? So if you can solve it very well, you will have 128. That's your final answer. Remember, you open this bracket first. 4 minus 2x times 4 minus 2s, right? This is 60 minus 8s.
Hello, sir.
Yes.
Please, can you move the edges? I'm not seeing it. The last this thing, can you move it to?
Is it okay?
Yes, yes. Okay. I can see it now. Thank you.
So this one, when you said 4 multiplied by 4, 16, 4 multiplied by minus 2s, minus 8x, minus 8x plus 4x squared. So you add this one together, 16 minus 16x plus 4x squared. So this is what you will substitute where you have x squared. Where you have x squared, you substitute this one there. When you have this, then for the last one, for the one with cube, remember you have 4 minus 2s cubed. So all you need to do is just to multiply this one, just say that, which is equal to 4s squared minus 16x plus 16 multiplied by 4 minus 2x. So that is what equals to your cube. So you multiply this one by one, you have what? 60x squared minus 16 times 4. 64, right?
Yes.
Then 16 times 4 again plus 64. Then minus 2 times minus this. As positive, you have minus 8s cubed plus 32x.
Hello, sir.
Yes. I'm with you.
Sorry to take you back. What you did immediately after that bracket up, what you did, I think you were supposed to factorize 4 minus 2s out. So how come you are using 4 minus 2x to multiply 4 minus 2x?
I'm just explaining this. Remember, you can't factorize x out because you have to integrate with respect to x.
Okay.
The last one is to integrate with respect to x. The last integral here.
Okay, sir.
Remember what I did? I substituted 4 minus x from the upper limit of y. Now,
Okay.
I'm just trying to assist you guys. The final answer you will get is this 128. But I'm giving you the step how to reach 128 because I'm not going to solve everything. I just want you guys to go and do it by yourself. Now, that's why you see 4 minus 2x squared. I open it. I said this is what you put here.
Okay. Okay.
Then the same thing you will put here.
Hello, sir.
Yes.
Please, can you take your screen back to the question, please?
Yes.
Okay, sir. Thank you, sir.
Is that okay?
Yes, it's okay, sir. Thank you.
So you're just joining us, right? You're welcome.
Yes, sir. Thank you,
Okay.
sir.
So
Okay.
don't worry, you watch the video. I will try and upload the video on time so that you guys will be able to watch it. So I'm just expanding this for you guys to see that it's raised to power 3. The one with raised to power 3 is the one I'm doing. I said, since you know raised to power 2 to be this, multiply it with 1 of raised to power 2. Then multiply, when you open the bracket, you have this 2x minus 2x multiplied by 4x squared. It will give you minus 8x cubed. Minus 2x multiplied by 16. It will give you positive 32x. Minus 2x multiplied by 16 will give you minus 32x. This will be squared, while this will be ordinary. So you can add them together. We can start with by saying minus 8x cubed. Let's add all the positive, all the square together. 16 plus 32, it's minus 32 plus minus 64 is what? (96x). Then substitute this one plus 46 plus 64 rather. So this is what you will substitute where you have s cubed. This is equals to 4 minus 2x cubed. So substitute this one back to it, then open the bracket, then now integrate. Multiply everything into it and substitute your 45. Substitute your limits and multiply by 45. At the end of the day, you have 148, 128. If you do it, that is what you will have. Your final answer will be 128. Thank you. Have I answered your question, please?
Yes, sir. Please go up a little bit, just one step. I want to see that expression. Just one step.
Can you see it?
Yes, yes.
So the first expression is what I was telling you is your where you have 4 minus 2s all squared, substitute this one there. 16 minus 16x plus 44s squared. Are you getting it now? Then where you
Yes,
are up,
yes, sir.
so just substitute it here and here. Then multiply them with what is outside. Then for the s cube, you have to substitute everything here
Okay.
to where you have s cube. Remember, s cube is somewhere here.
Then the last one.
Remember, this is s cube raised to power 3.
This is a long calculation.
Can you see it now? So when you have s cube there, and you've expanded s cube, you put this one there. When you put this one there, then expand them one by one. Can someone just write this one down? Write this down and write this one down too. Can you write it down? Or do you have it in your notes? Are we there? Okay, let's move on. Are we there?
Yes, sir.
Okay, let's look at the Green's theorem. Green's theorem. Green's theorem is the name of person that discovered this particular theorem we're about to solve. And says that if two function p of s comma y and q of s comma y and their partial derivative are single value, and continuous over a plane region R bounded by a closed of C, then we have integral closed P dx plus Q dy to be R bounded on R partial Q over the X minus partial P over the Y to be dA. So at the end of the day, we know what we have here in this case over the areas that we are dealing with. So let's look at it. So we have the formula already. Let's write this down. Verify we have to verify Green's theorem. This is theorem in XY plane. For integral of C of XY plus Y squared dx plus X squared dy, where C is the closed curve of the region bounded by y equals to x and y equals to x squared. Don't forget the formula above says p dx plus integral of p dx equals to q dx equals to q dy. Is the same thing as partial derivative of q with respect to x minus partial derivative of p with respect to y in a particular area that we are dealing with. So the solution will be, let's solve it. Integral of p dx plus q dy. You just have to first of all write the formula down. Is equal to integral of, with respect to r, the q the r the x minus the p dy. So now let's look at this region we are talking about, the areas we are talking about. So in this case now we know that this is talking about y equals to x. But at the initial stage, we have 0, 0. So remember, at y equals to x is at the initial stage. Then we have another point called x squared, which join this. Is an extension here. So here we have it to be, we can call this particular one to be 1, 1. So, but this plane is equals to x squared. Now, we have along y equals to squared. What is our dy? Our dy will be what? 2x dx. That's the meaning that it differentiates x squared. What do you have? We have it in this format. So we can go back into the board and substitute our x. Look at this equation we are given. We are given this. Don't forget we are given xy minus or plus x squared. Let's see. Plus y squared rather. But in this case now, don't forget we know our y to be x squared. Substitute your y there. Let everything be in terms of x. For everything to be in terms of x, okay, let me just write the equation first so that you will You can follow with me. The x plus s squared dy. Now, let everything be in form of x. That means if everything will be in form of x, we are going to have this. That's why we need to first of all differentiate this gentleman. So in case we have this one, we have it to be anywhere you see y, substitute x squared. So we have x into x squared plus s squared dx plus s squared. You know we have the y. Substitute the y. 2x dx. So I can open it. I know the integral portion of this one will be 0 to 1 based on what I was given, because I know the part is 0 to 1. So here we have it to be integral 0 to 1 to be s raised to power 3 plus, but this is, sorry, this is y squared will be y s raised to power 4 dx plus x squared or plus s cubed, 2s cubed, 2s cubed dx. Now we can merge everything together because they are all with the x now. Let me just, I can even remove this one. So what do we have at the end? We have to. So what do we have at the end of the day? You can integrate this one. What do you have when you integrate? Anybody?
X raised to power 4 over 4.
You can add the 3 together. You agree with me? I can have
Okay,
3s raised to power 3 plus s4.
Okay.
Because the power are the same.
Yes.
So for me to integrate this one, I have 3 raised to power 3.
X raised to power 4.
3x4
4.
divided by 4 plus x5 divided by 5. 0 to 1. So if you substitute this one very well, you have 19 over 20. 19 over 20. Remember, we only did the one with along with x squared. Now let's look at the one with along with x. So along y equals to x. So the y is equals to the x in this case. That is, when you differentiate what it means is, let me explain. If you differentiate the both sides, it will be the y, the x, right? The y, the x equals to 1. Because we are differentiating x, it will equals to 1. So when you cross multiply, which implies that the y equals to the x. So in our original question, we can substitute it. But the table will turn in this case. So it's instead of 1 to 0, it will not, instead of, it will not be 1 to 0 into x plus x squared dx plus,
hello.
Yes.
Sorry, can you just help me go up a bit? I missed the line before 19 over 20.
Are we there now?
Yes.
So remember, let's go back to our diagram. So remember, we are looking at this one now. It's going to be here from 0. The upper limit will now be 0 from the origin to 1. From 1 to 0 rather. So that's what we have. in this requirement. But when you add everything together, integrate them, you have when you integrate this, when you add this together, you have x squared. You have 3x squared dx. Because this will be 2x squared plus x squared will be 3x squared dx. Integration will be 3x cubed over 3 to 1 to 0. At the end of the day, you have minus 1. Now, the requirement, remember we are trying to verify the Green's theorem. So the requirement in this case, when I said they require line integral will be, remember the first analysis, we have 19 over 20 minus 1. We now have minus 1 over 20. So that is what we have for the line integral. For the line integral we did. Now, for us now to solve, we've not solved the problem. We are still working on that. Let's see whether we are going to have the same thing. Whether the both of them, because we have to prove that the two of them are equal. The two of them are equal from here. That is, you have to prove from here to this place. So that is, you have to prove that what you have here is the same thing as what I have here. So let's see, how do we do that? It's very simple. Remember, we've done the one of line integral. That is, the line integral is equal to W integral. That's what the theorem is all about. So meaning that after we've solved all these, we have this. So, but now let's look at the second part of it. The second part of it says, integral region, the q, the x, minus the p, the y, the x, the y. So, if that is the case, what is we don't need to use our diagram up to be able to specify our function, how we are going to move from 0 to 1 and from s squared to x. So it's going to be, let's first of all solve the problem. Look at this. Who can remind us our P and our Q? What is our P? Remember, the integral says sy plus y squared dx plus x squared dy. So we need to know, this is our P, this is our Q. So when the question now says dq dx, can we differentiate dq dx now? Anybody? Dq dx is what?
The QDX should be y, that will be 2x.
The q dx is 2x. Y the p, the y is what?
2y.
Nope. Remember, there is x somewhere. X and y is the first one. You differentiate y, you hold x constant. You have it to be what? X plus 2y.
Okay.
Do you agree now?
Yes, sir.
Now
Yes,
that
sir.
we know the definition of what is here, we can substitute these two back into this and integrate it. So it's going to be integral of x of 0 to 1 and x of y of x squared to x. So what do we have inside? We have x. They said 2, okay, dq the x. Let's go first of all. Dq the x is 2 minus x minus 2y. Remember, it says dq dx minus dp dy. Dp dy is x plus 2y.
Plus 2y.
And the negative will affect the parentheses when you open it. Will be minus x minus 2y. Now the x, the y. So we can first of all solve our y as usual. But before then, I can reduce this one by saying s equals to 0, 1, x squared, x. 2x minus x, you have x minus 2y. dy dx. So I can go ahead and integrate this one. If I integrate this one, what do I have? With respect to y, I will have xy minus 2y squared over 2, making x squared to x dx now. So this one will cancel this. What do we have? We have integral of 0 to 1. Substitute the value. Upper limit minus lower limit, meaning I have s squared minus s squared. You see? S squared minus s squared. Minus lower limit. Lower limit will be s cubed minus s squared. That will be my lower limit. Will be x4 rather, s raised to power 4, because my y is squared here. It's going to be s raised to power 4 dx. So the entire system here will be 0. And I will be left with 0 to 1 into s raised to power 4 minus s raised to power 3 dx. So we can integrate this. What do we have when you integrate this? You have
X raised to power 5
over 5
minus x raised to power 4 over 4.
0 to 1. So let's substitute. What do we have? You have it to be 1 over 5 minus 1 over 4. When you do it very well, you have minus 1 over 20. So when you are asked to verify something, they want you to check whether what you have. So you can see that our formulas are correct, are intact. When we use single integral to solve it, the line integral, we did that. And at the end of the day, we have the same answers. Look at it, we have it here. It simply means left hand side is equal to right hand side. Therefore, left hand side equals to right hand side. So we've established the Green's theorem. So just look at your past question and lay your hands on as many questions as possible to solve them. All they want you to do is just to prove that the left hand side is equal to right hand side the other way. when they ask you to verify. Guys, thank you.
Hello, sir.
Thank you, sir.
Yes.
So what if at the end of the day, that value did not give us what we did when we did the single integral?
That
we did
means
not get it.
it's also part of the answer. If it's not giving you the same thing, that means it does not hold. The Green's theorem does not hold at that point.
Does not hold.
But you need to also be careful. You can see the way we are solving it. You need to take your time and solve it one by one,
Okay.
and cross-check that. How many hours do they normally give you guys?